All right, let's talk about these sampling distributions for the sample means problems. Here we go. All right, so here we were wondering if the machine is malfunctioning. So, what happened was we knew that the average length that the boards would be cut is 22 feet, but we took a random sample of 60 boards and that sample averaged 22. Okay, so here is where if the boards are centered around, if the true average is still 22, then the boards would be centered around 22 for the average of all the X bars. They would all be centered around 22. But we got this one that was an X bar at 23. So if we got an X bar out there at 23, was that unusual? And yes, it was. It was over 2.5 standard deviations away. So this was not really due to sampling variability. This makes me think that the center of all the X bars is not centered around 22. It's actually centered higher. Think about this whole blue picture here really is probably shifted higher because this X bar needs to just be within sampling variability of that mean. Okay, so since the sample is more than 2 standard deviations above the mean, I think the average length is actually more than 22. Therefore, the machine could be malfunctioning. Okay, next. Okay, so on this one, we were talking about the weight of the passengers. And so the elevator says they can carry up to 5,000 pounds safely. And the sign and will allow 32 passengers. So what happened was that where that came into play was for the X bar. Okay. So um, we're told that the average weight of a person is that 148 pounds with a standard deviation of 15.2. Okay. But if 32 people can go in the elevator, then the elevator is allowing 156.25 per person on average. Okay. So that's kind of what's happening. So here, let's see what is asking. So should the sign change the number of elevator passengers allowed? Okay. So, what that's saying is that here's kind of a picture of what's going on. Okay, so let me show you. What we have happening is this. Here is what the elevator holds. Okay, and if the average passenger on the elevator is truly around 148 pounds, okay, then all of our samples of 32 passengers are going to average 148 pounds. Sometimes the average will be a little less, sometimes the average will be a little bit more, sometimes this, sometimes that. Now, the elevator is going to allow up to this amount here, 156.25 per person on average. So the question is, so where is that? If this number if that sample was close to the average, because this is the limit. This is as much as is being allowed. Okay. This is where it becomes dangerous. So essentially, you have to be, you have to be 3.07 standard deviations above the mean to be dangerously close or above the limit. So that's good in that that tells us that we're probably they're being on the safe side. So because if people are really 148 pounds on average, then we're probably not going to have this problem here. Now, if um, if the elevator, if they put this number was less or more, I don't. Anyway, I'm going to get myself confused the way I'm stating it. But here we go. So the number of passengers allowed does not need to be changed. because a 5,000-pound limit is more than 3 standard deviations above what's going to happen on average. Okay, so that's good. Therefore, I don't think having 32 passengers who average 148 pounds each will be exceeded. That limit will not be exceeded very often. In fact, only the weight limit will be exceeded about 0.11% of the time. So I norm CDF'd from this 3.07 out to infinity. So that looks pretty good. So there you go. All right, next. So here was the machine cutting the steel bars. We wanted to cut them to 20 feet in length. And so we took a sample of 40 and we wanted to not differ from the mean by more than 0.1 feet. So in my mind, that means I've got 2x bars. I need to be here in this section, 19.9 or 20.1. Okay, so I then said, okay, well, let me find out what proportion are going to be in there. So negative, I think that's what it asked for. What's the probability that the sample will differ by no more than 0.1 feet? So what's the probability that the average of the 40, so see, then we have this smaller standard deviation, and that's what I used here when I found my z-scores. So there are my two z-scores, and then I norm CDF'd between them. Oh, so yeah, that's going to be the differing by more than that, so that's going to be this area down here and this area up here. So I found those two areas and then I added them together. Of course, you could find the middle and subtract it from 1. Okay. So there's 11.18% chance that the average of the 40 bars, that the X bars out there on the edges will vary by more than 0.1 feet, be off. Okay, so here was a traffic study. And so we got the occupants in the car. We're averaging 1.85 with a standard deviation of 0.31. We have sample size. They're going to take samples of size 64. So the question, find the probability that the average number of occupants is between 1.85 and 1.9. So I then am knowing that it's for standard deviations that are 0.039 because I'm taking samples of 64. So the first z-score is 185, which is the mean, so that's a 0. And then the second z-score is 1.9 minus the mean over the standard deviation is 1.28. So I'm just going to norm CDF between 0 and 1.28. So 39.97% chance that the average of 64 people will have between 1.85 and 1.9 people in the car. All right, and here's the next one. So we know, I think I actually, is this? No, but I think there's a problem somewhere that comes up, and it was actual Aledo High School data, and I looked it up to get the actual Aledo High School data. So when we come across the ACT one for that, I looked it up. And here we go. Scores of individual students on ACT are normally distributed because it's a standardized test with a mean of 18.6 and a standard deviation of 6. So there we have that. They take a sample of 36 seniors. And so we just wanted to know what's the probability you get this 19.2 or higher, this X bar of 19.2 or higher. So I'm just going to get a z-score for that. Okay. My X bar minus the mean over the standard deviation of X bars was 0.6. So 27.43% chance of getting that random sample of 36 seniors who average 19.2 points or more, if the average is 18.6. So this implies that there's really no evidence to suggest that the average ACT score of the seniors at this particular high school is above the national average. See, so that's kind of the implications of where we're headed with this. So we might take a year's, and I did that with our Aledo data. I took a year of 2018 and I took our Aledo data. And so I was seeing if the average ACT for Aledo students is higher than the state average, is what I compared it to. And so this shows if Northside, the sample I got at Northside High was 19.2. That could just be because of sampling variability because of the seniors I selected. So this doesn't really give me evidence to say that 18.6, that the average at Northside High is any different than whatever is this the national ACT one, whatever they say. Okay. But anyway, so there you go, is above the national average. But we'll see with our Alito data, we're like, I think, over 3 standard deviations above the mean. So that tells me that we have an overall average that is higher than that state average. Okay, I think that's all that we did. And then there's the next section of notes. All right, hope that makes sense to you.